Okay, here is another application of uh, differential equations. It's called Newton's law of cooling. Now, the law states that the time rate of change of temperature of an object dt exposed to a medium temperature Tm is proportional to the difference between the temperature of the object and the temperature of the medium. So mathematically stated, this is the same as dt is equal to k t minus tm. Now the solution, the solution of this differential equation, okay, here is this one. Temperature is equal to Tm plus To minus Tm e to the kT, where Tm is the initial temperature of the medium and T sub O is the initial temperature. Now let's do the derivation. Okay. Now let's start with this formula. dt is kT minus Tm. Okay. Now separate variables. Okay. You have dt over, you have dt over t minus tm is equal to k dt. Integrate both sides. Okay. Integral of dt over t minus tm equals k dt. Okay. Integrating, you have ln of t minus tm is equal to kt plus ln of c. Solve for t minus tm. That's the same as e to the kt plus ln of c. Of course, this can be written as the same as e to the kt times e to the ln of c, which can be written as also c e to the kt. So therefore, you have t minus tm equals what? Equals c e to the kt. Now substitute initial condition when t is 0. Okay, when t is 0, t equals t sub o. Substitute that. Okay, substitute that. We have, of course, we have we have okay, here we have c equals what? Equals t sub o minus t sub n. Of course, this is c e to the 0, and you know that e to the 0 is 1. So we have c is t sub o minus t sub m. Then of course we'll have c equals t sub o minus t sub m, and t minus tm equals t sub o minus, okay, this is plugging t already. T minus tm is t o minus tm e to the kt, and transferring t, you have this function time. Temperature as a function of time is equal to tm plus t sub o minus tm e to the kt. Okay, let's have an example. A thermometer reading 10 degrees centigrade is brought in a room whose temperature is 18 degrees centigrade. 1 minute later, the thermometer reading is 14 degrees centigrade. How long does it take until the reading becomes 16 degrees centigrade? So this is the formula that we're going to use. T equals Tm plus To minus Tm e to the kt. Then this as the condition. The initial temperature is of course 10. That's To. The temperature of the medium is 18. This is what? This is the where the thermometer is transferred to. And when T is 1, the temperature becomes 14. This is the one that we're going to use to solve for k. So we have t sub t is tm plus to minus tm e to the kt. Then substitute the values 18, that's tm plus 10 minus 18 e to the kt, or that's the same as t sub t is 18 minus 8 e to the kt. We're going to use this value to solve for k. So when t is 1 is 14, that's 18 minus 8 e to the k. You solve for k. Okay, transfer that 14 minus 18 there, that's negative 4, and get the ln of both sides. So you get k is ln of negative 4 over negative 8, that's ln of 1 half. Okay, sometimes you will have to find the value of this. This is approximately equal to 0.693. Okay, then you now have the what? You now have this model temperature as a function of times 18 plus 10 minus 18 e to the ln of 1 half t. We had filled up this model already. Then how long does it take until the reading becomes 16 degrees centigrade? And we're looking for what? The time. So plug the value, find t when t is 16. Okay, we use the formula that we derived. This is t sub t is again 18 plus 10 minus 18 e to the ln of 1 half t. And then substitute the value of 16 there, and then solve for t. Now this can be written as negative 4. Negative 4 is equal to what? Negative 8 e to the ln of 1 half t. Okay, and then this is 4 over 8 is 1 half. Uh, I'm sorry, this is negative 2. Negative 2. So this will become negative 2 over uh, okay, this is supposedly what? Negative 2. This is negative 2. Oh, that's so negative 2 over negative 8, that is 1/4. It's the same as e to the ln of 1 half t. Then get the ln of both sides. You have ln of 1/4 equals what? Rather ln of this is already what? This is already ln of 1 half t. 1 half t, and solving for t, that's the same as what? That's the same as negative ln of 4 over negative ln of 2, and of course this is equal to 2. So the answer is time is 2 minutes. Okay, let's try to solve this problem using a technique in the calculator. Okay, this is the original problem. No? Here in the problem, this is our what? Initial temperature, which is T sub O, and then this is the temperature of the medium. Okay, and then 1 minute later, the temperature of the reading is 14. This is temperature as a function after 1 minute, and here the temperature as a function of time is equal to 16, where the time is unknown. Okay, now alright, you go to the calculator, mode 35. This is 4991 ES Casio. Of course, if you have any calculator, we have a model with a statistics application with the model y is a e to the bx. So this is really have to plug, okay, because we're going to set a model that is 18. This is the temperature of the medium minus y. This is the temperature at any time is equal to a e to the bx, where your y is temperature and your x is time. Okay, so I'm sorry, this is small letter t. This is t, small letter t, time. So plug this. When the time is 0, the temperature difference is 18 minus what? 18 minus 10. Okay, that is equal to 8. And when the time is 1, that is known, the temperature difference is 18 minus 14, that is 4. Okay. Then enter clear first in order for you to clear the screen. Then input shift 151 equals, you will get A is 8. Input shift 152 equals, you'll get B is negative 0.693. Therefore, this is what? This is 8. Okay, and that B is what? Negative 0.693. Okay, so you have the model 18 minus y is equal to what? Uh, is equal to, so 18 minus y, that's the same as what? A e to the negative 0.693x. So you see we have the mathematical model already for what? For the Newton's law of cooling for this problem. Okay. So you now get the model, and then to get the time until the reading becomes 16, get the difference between 16 and rather 18 and 16. What is 18 minus 16? That is 2. And then 2 shift 154, you get the time. 2x2 is 2 minutes. So this is the what? This is the time now is 2 minutes. This is the answer. Okay.